the topic which we're going to discuss as a new chapter is measures of dispersion. So what is measure of dispersion is how we're going to introduce the concept. Now, in statistics, we have seen the measures of central tendency, that is, the measures of central tendency being mean, median, and mode, which are called the measures of central tendency. That is, these three factors of statistics, that is mean, median, and mode, describe the central tendency or the behavior of the data. So it gives us on how we can observe the center of the data out of all the given data points. So that was discussed in the previous session of the data points. Now coming to the measures of central tendency, sometimes what happens is, if I just know the central value, say for example 1, 2, 5, 7, 9, 8, 6, then I know that my median, say for example I take the median, and my median in case of these scores is 7. That means my central tendency gives me that all the data points are dependent on 7, but this is not sufficient to examine the data, because the center value being 7 is the median which measures the central tendency of all the 7 data points given here. But when it comes to discussing the nature of the rest of the data points, this measure of central tendency alone is not sufficient. So we have to even study the measure of variation, that is, how the data points are varying accordingly as we take in different order, is how we also consider. So considering the variation of the data is nothing but measure of dispersion. Considering the central tendency of the data is measure of central tendency, and considering the variation of the data into account is nothing but the value which we find called measure of dispersion. Now that to measure the central tendency of the given data points, we have three factors in statistics which measure the central tendency, that is mean, median, and mode. Similarly, the measure of dispersion also has three basic tools in statistics through which we measure the dispersion or the measure the variation value. So let's see how we can find through a live example, or why we need to find the measure of dispersion through a valid live example in real life. Now let's see the need of considering the measure of dispersion through this live example. Why do we need to consider measure of dispersion into account when we do the statistical survey of the data points, is the biggest question which is supported through this real life example. So for example, I take a problem where these are the runs scored by batsman A. The first row gives runs scored by batsman A, and this gives runs scored by batsman B, is how we have the two different scores as given in the two different rows of this given problem. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 matches, international matches, in which the batsman A has scored in each of the 10 matches with different scores, and the batsman B in each of the 10 matches has scored 10 different set of scores. Now with this, clearly I understand that my mean or arithmetic mean, which is a measure of central tendency for runs scored by batsman A, is nothing but 53, which is obtained by average sum of all the scores by total number of matches the batsman has played. So mean of scores, runs scored by batsman A, is 53, which we get when we add and divide by 9 by 10, when we divide by 10. So in this case, I get this to be this 530 by 10. On adding, I get this to be 53. Similarly, let me also calculate the mean of scores scored by batsman A. So interestingly, even for batsman B, it is 53. That is, the mean of even the scores of the batsman B is also 53, which we get when we add up and divide by 10. Similarly, I want to calculate the median of runs scored by both batsman A and B, which is also 53. That is the middle value which we consider in case of this. So my mean and median being 53 gives me that the measure of central tendency, that 53 is the value on which the whole of the data points are centered, is how we get from the measures of central tendency. That implies 53 is the measure through which all the given scores are centered. But this may not be always true, because is it that this is always same when we take into consider other data points? That is, what if I take the least of the score and the highest of the score, which are totally different from the 53 which is obtained as the core middle value or the middle score. Now in this case, my least is found to be 38 and my highest is found to be 60 or 76. So these values may not give a complete picture or a satisfied picture on the central tendency or the middle value which we have obtained. So 53 being the measure through which all the given scores are centered may not be a valid measure, but it needs something more information for this kind of statistical survey. So my question here is, based on these two medians being same, my question here is, can we say that the performance of two batsmen is same? Is the biggest question here, which says, can we say that the performance of two batsmen is same? No, certainly the answer is no. Why? Because the least of the scores which the batsman A has scored is 2, and the highest which the batsman has scored is 116. But in case of batsman B, the least of the score is 38 and the highest score which the batsman has scored is 76. So certainly the performance may not be the same, because there are various scores in each of the matches which are differing for batsman A and batsman B. So the answer for my question, can we say that the performance of two batsmen is same? The answer is strictly no. So therefore, the measure of central tendency is not sufficient in measuring the statistical data. We need something else more to measure the given data points through the complete statistical survey. And that measure which we're going to study is measure of dispersion, or which is also called variation, measure of variation, which may give a more clear picture. When we measure the dispersion or variation, we can give a more clear picture on whether the performance of batsman A or the batsman B is more or good. Therefore, variability or examining the variability along with examining the central value of the given data is equally important, is how we understand through this real life example, which put forth the question, can we say that the performance of the two batsmen is same? Certainly with the measure of central tendency, we cannot predict the performance of the batsman A and batsman B through their individual scores in each of the 10 matches. This requires even variability or dispersion which needs to be considered. Hence, the topic measure of dispersion, which is essential in statistical survey of given data points. So let's compare the two measures in the study of statistical data. One is measure of central tendency, which we estimate through mean, median and mode, and measure of dispersion or variation, which we have as other measure. Now this gives us a rough idea where the data is centered. That is, it gives a rough idea on which region the data is centered. And this gives a rough idea on where the data varies. Is how we understand the measure of central tendency and the measure of dispersion or variation of the data. So based on this, we can make a more statistical survey on not only that identifying the region where the data is centered, but also on where the data varies, including all the data points taken into consideration. So therefore, it is very important that in the branch of statistics, measure of central tendency and measure of dispersion are equally important in its examination. Now it is very important to note, now that we have compared the two measures, one is the measure of central tendency and measure of dispersion. Now the note comes where it is very important note which says that measure of dispersion, which we have taken in the later case, determines the reliability of the average of entire data. That is, the average which can be considered in investigation, that is the representation of the average in the entire data, can be estimated through the measure of dispersion, because the measure of dispersion determines where the data is varying more and hence its average changing accordingly through that varying data. This is how the measure of dispersion helps in determining the reliability of the average of entire data. This is a very important note to make in connection between measure of dispersion and measure of central tendency. Now let's see the different types of measures of central tendency as we discussed in the session. Just like the measures of central tendency which we have discussed is based on three types. One is calculating the mean, the median and the mode. Similarly, the measure of central tendency, the measures of dispersion or variation has three types of, or the three methods through which we calculate the measure of dispersion. So let's see what are the three types which we have. One is the range, which is one of the methods through which we can find the measure of dispersion of the given entire data. Then the next is the mean deviation, which also helps in finding the measure of dispersion or variation of entire data. And the next is the standard deviation, which also helps in measuring the variation of the data from the given data points. So with these three, range, mean deviation and standard deviation, we try to take each of them and then define respectively the range, the mean deviation, and the standard deviation. Now, to make a note here, next, measure of dispersion computed for a distribution is called statistic. So if we compute measure of dispersion for a distribution like the distribution table, frequency distribution table, then that measure of dispersion computed is called statistic, is how we understand the various statistical definitions in discussing the measures of dispersion. So now that we have defined the three types of measures of dispersion and the reason for inclusion of measure of dispersion in analyzing or exploring the data, the first of the measure of dispersion we call as range. Then the next is mean deviation and standard deviation. So now let's study in brief about the first measure of dispersion called the range. So what is a range? There are two types of definitions for the range. One is for the ungrouped data and for the grouped data. So I define the range for two separate sets of data. One is the ungrouped data and next is grouped data. Now generally we know what is ungrouped data, that is when the data is given directly as scores, we call that as ungrouped data. So in case of ungrouped data, the range is defined as is the difference between the maximum value, that is the greatest value, is the difference between the maximum, that is the greatest value, and the minimum, which is the smallest value of the given data. So here it is the difference between the maximum and the minimum. It's quite simple that when I have the data as ungrouped data, then in that case I have the range which is calculated by subtracting the least value from the highest value picked from the entire data. So let's see how we can understand the group data. So in this case, range is the approximation of the difference between the upper limit of highest class and the lower limit of the lowest or smallest class, is how we define the grouped and ungrouped data. So usually grouped data is when we have the frequency and the data given in column wise frequency table. So with these definitions we define range in their own respective manners. So let's see how to calculate range for each of the grouped and ungrouped data. Now let's see an example problem for finding range for ungrouped data. Now I have the scores of batsman A and batsman B in 10 different matches which I have taken in the previous session of the problem. Let's take the similar problem in understanding the range for ungrouped data. Now here, this is the runs scored by batsman A, and this is the runs scored by batsman B, which are given separately in the first and second row respectively. Now for these 10 matches, now these are the runs scored by the batsman A in each of the matches, and these are the runs scored by batsman B in each of the matches. So with this, I would like to find initially the range of A. So the range of batsman A is calculated for ungrouped data with the previous formula, the maximum minus minimum. Therefore, to find the range of A, this formula is maximum value minus minimum value. Now in the first row, the maximum or the highest runs which the batsman makes is in the 10th match, which is 116, a century. Now the lowest score is 2, which is made in the 4th match by batsman A. So my range is maximum value minus minimum value, or the highest value minus the lowest score. Then the highest score being 116 comes first, and the lowest score being 2 comes next. Therefore, the range is 114 for batsman A. Similarly, let's find the range of the batsman B, or the range of the runs scored by batsman B. So proceeding in the similar manner, I get range of B, that is the range which is max minus min. My maximum score or the highest scores is in the 9th match for batsman B, and the lowest scores are in the 2nd match by batsman B. Therefore, in this case, my range is 76 minus 38, which gives 38. Therefore, I got the range of A as 114 and range of B as 38, through which I am going to measure the variation of scores of the batsman A and batsman B in all the 10 matches. So therefore, in case of range of A being 114 and range of the batsman B is 38, which clearly makes me understand that here, so here we clearly see that range of A is greater than range of B. That means when I say higher the range, the more are the data points scattered or dispersed or varied. So therefore, in case of A, that implies the runs are scattered or dispersed far apart in case of batsman A. And when the range is reasonably less, then that implies that the runs are closer to each other. The data points are less dispersed. So in this case, the runs are closer to each other. They are quite near in the case of each of the data points or each of the scores, and hence less scattered or less dispersed. Now that we have done this problem, we understand now that the significance of range is that higher the range value, more are the data points scattered or dispersed far apart, and lesser is the range, as in case of batsman B, lesser is the dispersion, that is, the data are closer to each other and very much in relation to each other. As we can see here, all the scores are very reasonably closer to each other. 45, 44, 52 are quite closer, but when I see here 28, again 70, 30 and 2 and again 42, this gives me a reason that the run scored are not closer to each other, but they're far apart, where the lowest score is 2 and highest is 116, next is 5. So consistently the batsman A is not in consistently good performance. He is on and off with good performance, bad performance, good performance, bad performance, very good performance is how we see. But for batsman B, consistently the batsman performance is quite good, reasonably on average, is how we understand through finding of range for ungrouped data. Now let's see how we can find the range for group data. So as I can see in case of this, I see that this is clearly a frequency table or a grouped data. So in case of this group data, my class interval is ranging from 5 to 20, 20 to 35, 35 to 50 and 50 to 65, and the frequency is 3, 1, 4 and 2. So for this, we have for group data, the range is given by the formula upper limit of highest class minus lower limit of lowest class is what we get. So my upper limit of my highest class is this being the highest class and this being the lowest class. Here we have the upper limit. So this is highest class and this is lowest class. So my upper limit here is this and my lower limit is this, which I am going to subtract. Upper limit of highest class minus lower limit of lowest class gives me 65 minus 5, that is 60. Therefore, range is 60 for this frequency table is how we understand the range for grouped data. So finally we understand that the range is the highest value minus the least value of the entire data which we consider, that is the highest being this and the lowest being this, are both similar in case of grouped and ungrouped data. So let's see how range is applied more practically in real life and its limitations in real life. Now comes the discussion on limitations of range. Now range is said to be a crude. Range is the crude measure of dispersion, because as we understand, range is the highest minus lowest value. We are not justifying the whole of the data by considering all the data, but only the highest and the lowest. Therefore, since it considers only the extreme values, range is the crude measure of dispersion, since it takes into account only extreme values, is how we understand the limitations of range. But we understand, however, that range measures the variation of data to some extent. Range measures variation of data or scatterness only to some extent, but not perfect. And therefore, these are the two limitations of range which makes us search for a more modified measure of dispersion, which we are going to discuss. Now comes the discussion of mean deviation. So the word mean is already dealt in the measure of central tendency, mean, median and mode. So deriving the measure of dispersion from the measure of central tendency is what we are going to do in case of mean deviation to modify, because range does not tell us about the inclusion of measure of central tendency or does not tell us about the dispersion of the data through a measure of central tendency. Hence, it is very essential that we modify the limitations of range into a more better measure of dispersion, that is mean deviation, which takes into account the measure of central tendency. So let's see what is mean deviation and through a live example out here. So here mean deviation is obtained from either mean, mostly which we take, or through median. So these are the measures of central tendency through which the mean deviation is obtained, that is through mean and through median, which we generally discuss. But mean deviation can be obtained from any measure of central tendency which we use through the process of finding the mean deviation. But let's see here the mean deviation through mean and mean deviation through median in two different classifications. So here we find mean deviation from mean and from median, and again this has two different classifications, that is one for grouped and for ungrouped data. So mean deviation from mean again is classified into finding the mean deviation from mean for ungrouped data, and this is for grouped data is how we understand this. Similarly, finding the median for ungrouped data, and this is for grouped data is how we classify the different ways of finding mean deviation from mean and from median for both grouped and ungrouped data. So let's see the four types of classifications as done respectively through the different and respective methods. So let's see how we can find the mean deviation from mean for ungrouped data. So here I consider the discrete data x1, x2, x3 till xn. So each of them which are called n observations. So I have totally n observations x1, x2, x3 till xn. So let's see how we can find the mean deviation from the mean, using the mean for this ungrouped data. So in this case, my step 1 is to find arithmetic mean x bar, which is denoted with A. I'm going to find the arithmetic mean, which we already know how to find, denoted by x bar, which I denote with A. Then my step 2 is to find xi, the deviations, find each of x1 minus a, x2 minus a, x3 minus a, so on and so forth till xn minus a is what we need to find. So once each of the observation is subtracted with this mean, then my step 3 is to find the modulus of, then find absolute x1 minus a mod x2 minus a and mod xn minus a is what we're going to find, where negative sign becomes positive. So after we find the absolute values, we find the arithmetic mean of each of these absolute values, mod x1 minus a, mod x2 minus a, so on and so forth till mod xn minus a. Therefore, the mean deviation denoted by MD as a shortcut is given by sigma, that is sum of I running from 1 to n mod xi minus a whole by n is how we get the summation of this. So mean deviation is defined as sigma I running from 1 to n mod xi minus a whole by n. Therefore, using this, we get the mean deviation for ungrouped data. So let's take one example problem to understand this. Now let's take a problem in finding the mean deviation from mean for ungrouped data. So in this case, if I wanted to find the mean deviation for ungrouped data, say 6, 7, 10, 12, 13, 4, 12 and 16, then in this case I would like to find this using mean. So therefore I use the formula as discussed in the previous session. So in this case, the scores which are given are 6, 7, 10, 12, 13, 4, 12, 16. So totally there are 8 observations in the given scores. Now with this 8 observations, clearly I understand that my n is 8, or the number of observations is 8. And each of this is represented by x1, x2, x3, so on and so forth till x8. So using them, I try to just use the step 1 where I need to find arithmetic mean x bar, which is nothing but sum of all the scores by number of scores, that is 6 plus 7 plus 10 plus 12 plus 13 plus 4 plus 12 plus 16 by 8, and this on when added gives me 80 by 8, which gives me 10. Therefore x bar is 10. So once I get the arithmetic mean x bar equal to 10, which I usually denote with a, let's next find each of the deviations. So next, in finding the deviations, I clearly take first x1 minus a, which is x1, 6 minus 10, which is minus 4, then x2 minus a, that is 7 minus 10, which is minus 3, and so on and so forth, etc., until I reach the last. Then here I find mod of x1 minus a, that is minus 4, which becomes plus 4, and then I find mod of x2 minus a, which on finding the absolute value gives me 3, etc. So therefore finding each of them, therefore my mean deviation, which is given by sigma I running from 1 to n of mod xi bar minus xi, or it is a, xi bar minus a, or xi minus a by whole by n, through which I get each of the observations. Therefore, I get 4 plus 3 plus 0 plus 2 plus 3 plus 6 plus 2 plus 6 whole by 8, which is obtained by finding each of the deviations from A, such that this on adding gives me 26 by 8, that is 8 3 is 24, 3.25. Therefore, my mean deviation, which is calculated for mean for this ungrouped data, gives me the value 3.25 as obtained from mean. So this is how we find mean deviation using the formula as found here. Now let's see how we can calculate the mean deviation from median for ungrouped data. The procedure here is, if there are n observations, x1, x2, x3, so on and so forth till xn, then in the previous case, because we were to find mean deviation from mean, we have calculated the mean of the complete discrete data. But in case of this discrete data, I calculate median because it is from median that I had to calculate the mean deviation. So let the median, or it is calculate the median. This is how the step 1 procedure goes, where initially I calculate the median of x1, x2 till xn. So let me say the median which I calculated be some b, denoted by b. Then in my step 2, I calculate the deviations. I find the deviations of each of the observation, that is x1 minus b, x2 minus b, xn minus b, is how we get the deviations of each of them. So we find the deviations x1 minus b, x2 minus b till xn minus b for each of the observations x1 to xn. Next, in step 3, we find the absolute values, that is mod x1 minus b is what we find, that is all the negative values replaced with positive values is what we get in step 3. In step 4, find the arithmetic mean of each of these, is how we understand. That is, in this case, I get my median, which is, therefore, in case of this, I get my mean deviation for the given ungrouped data using median is obtained as mod sigma I running from 1 to n mod xi minus b by n. So this is as similar as the formula as obtained using mean, but the only difference being that here b is the median and in the previous case a was the mean, is how we find difference, but the procedure is the same. So let's take a problem to understand finding of mean deviation from median for the ungrouped data. So for example, the question is to find the mean deviation of the score 4, 6, 7, 10, 12, 12, 13, 16 using. So we'll see how we can find the mean deviation of this using median. So the given score is 4, 6, 7, 10, 12, 12, 13 and 16. So how do we find median? The first step is finding the median, taking them in order Now because they are already in order of the values, now let's see what are the middle terms. These two are the middle values. Therefore, median will be the average of these two data points. That is, median is 10 plus 12 by 2. That is 22 by 2, which is 11. So using the median as 11, we have the deviations which we need to be calculated. That is the deviations of each of the scores, which is obtained by subtracting 4 minus 11, 6 minus 11, 7 minus 11, etc. That is, which gives me 4 minus 11 is minus 7, minus 5, etc. is how we get each of the values. Now, next we find absolute values, that is mod. Then next comes finding the mod values, mod minus 7, mod minus 5, mod minus 4, etc., which gives us all the positive values, 7, 5, 4, etc. Therefore, let's see how we can find mean deviation from these of the procedures. So mean deviation is sigma I running from 1 to 1, 2, 3, 4, 5, 6, 7, 8. So n is 8 and this is b. So therefore, I running from 1 to 8 mod xi minus b by n, which gives me mod of xi minus b, that is 11 minus 4, which gives me 7, plus 11 minus 6, which gives me 5, plus 11 minus 7 is 4, 11 minus 10 is 1, 11 minus 12 is 1, 11 minus 12 is 1, and 2 plus 6, 11 minus 16 is 5 whole by 8 is what we get, which on simplification gives me 7, 5, 9, 14, 15, 16, 17, 18, 19, 1 and 26 by 8, which is 3.25. That is, the mean deviation of this data using the median is 3.25 as obtained in the answer. Is how we understand finding the mean deviation through median. So in this case, we find the properties where I find the mean deviation from median and mean. We have some properties which we need to discuss. Now, in case of the previous two problems which we have discussed, we had the same data considered for finding the mean deviation from mean and median. So we have observed that the value of the mean deviation was same when calculated through mean and also through median. The value was 3.25. But it is only a coincidence, but usually the mean deviation from mean and median for the same observation need not be equal. It is not compulsory that because the observation is same, the mean deviation as calculated from mean and median need not be equal, is how we understand the property. Though in the previous problem it was a coincidence that the mean deviation was equal for the same observation through mean and median. The second important property here is that if you take mean deviation as calculated from the three measures of central tendency which we have in the branch of statistics, one is mean, median and mode, then the mean deviation as calculated from median will give me the least value. Gives me the least value out of all these three, and hence this is called the minimal property. Now, as mean deviation calculated through median gives me the least value, this is called the minimal property of median, which we refer when compared with all the three measures of central tendency in finding the mean deviation. Now let's see how we can find the mean deviation for grouped data. Now that we have discussed about ungrouped data, now comes the question on how to find the mean deviation for grouped data. So in case of grouped data, we have two types of data which are considered, for which we need to find the mean deviation respectively. As we have studied that group data is again classified into two types, where we have discrete frequency distribution and the next is continuous frequency distribution. Then based on these two types of distributions, we try to study the mean deviation for a group data. So let's see how we can find mean deviation for group data. Initially, for discrete frequency distribution, where again I calculate through two means. One is using mean and the other is using median. So this is from mean and this is from median, where I have the two respective formula given by mean deviation in case of this given by sigma I running from 1 to n fi mod xi minus a by sigma I running from 1 to n of each of the frequency, as this is given, where a is arithmetic mean, that is a is arithmetic mean x bar, which is given by sigma xi fi, sigma I running from 1 to n xi fi by sigma I running from 1 to n of fi, which I get as arithmetic mean, where a is the mean which we are going to calculate here. Now let's see how we can calculate through median. That is, the mean deviation from median is sigma I running from 1 to n fi mod xi minus b by sigma I running from 1 to n of fi, which is the median in this case, where b is the median of this score. So in this case, b is the median, in this case a is the mean. So we have the same formula differing with a and b, because from mean we use the mean a, and from median we use the median b for calculating mean deviation in each of the cases. So let's see each of the case of finding mean and median for different respective formulae. So usually the discrete frequency distribution has the data which is given in the form of two rows. Usually the data and the frequency come as x1, x2, x3, so on and so forth till xn, and my frequency comes as f1, f2, f3 till fn respectively for each of this course. Is how we have this in discrete frequency distribution with data and the respective frequency, where we use the mean deviation formula as given here. So let's do one problem to understand this concept more better. Let's take an example problem. So for example, I have a discrete frequency distribution table xi and my frequency fi, which are given by 2, 5, 7, 8, 10, 35, and my frequencies which are 6, 8, 10, 6, 8, 2 is what we get. Now for this problem, I would like to find each of xi, fi, and then xi minus a, that is x bar, and then mod xi minus a is how I need to find each of these. Now what is the need for finding each of these three is the biggest question here, because my mean deviation, which is given as from mean as sigma I running from 1 to n fi times mod xi minus a by sigma I running from 1 to n of fi. Therefore, it is essential that I find each of xi minus a and mod xi minus a, and since my frequency a is given by sigma xi fi by sigma fi I running from 1 to n is how I need to find this and from the column. So after we find, we substitute them in the respective formulae and we get the mean deviation as desired. So let's find xi times fi, that is 2 times 6, xi being 2 and fi being 6. 2 times 6 is 12, 5 times 8 is 40, 7 times 10 is 70, 8 times 6 is 48, 10 times 8 is 80, 35 times 2 is 70 is what we get in the case. Now with this, I need to find xi minus a, but before this, I need to find a. So let's see how I can find a from here. Now this is sigma fi, which I can going to find from I running from 1 to 6, which will be 8 plus 2, 10, 16, 26, 26 and 14 is 40, 32 and 40. And then this will be sigma xi fi, which I will get as, on adding, it is 70, 140. So therefore, this on adding gives me sigma xi fi, which is nothing but 320. And from here, I got these two. I can find the arithmetic mean x bar or a, which I get by substituting sigma xi fi, which is 320, and sigma fi, which is 40, which on simplification gives 4 ones, 4 eights is 8. Therefore, a is 8, which I'm going to substitute in the mean deviation. So let's find the deviations xi minus a, that is 2 minus 8, which gives me minus 6, 5 minus 8, which gives me minus 3, 7 minus 8 is minus 1, 8 minus 8 is 0, 10 minus 8 is 2, 35 minus 8 is 27. Then I find the modulus of this. Then mod of minus 6 is 6, and mod of minus 3 is 3, and mod of minus 1 is 1, and mod of 0 is 0, and mod of 2 is 2, and mod of 27 is 27. now that I have to find summation of xi minus a or fi xi minus a, I also find fi mod xi minus a, which I need to find as multiplied, because fi mod xi minus a is this multiplied with this. So 6 times of 6 is 36, and then 8 times 3 is 24, 10 times 1 is 10, 6 times 0 is 0, 8 times 2 is 16, 2 times 27 is 54, which on sigma fi mod xi minus a, I running from 1 to n will be sum of each of them. So this on adding gives me the value 140. So using this a or using the values of sigma fi and sigma this, I calculate the mean deviation using this formula. So let's see how we can find mean deviation from this observed table. Therefore, when substituted for sigma fi mod xi minus a, which is 140, I get the numerator as 140, and then sigma fi is 40 as added with each of is 40 out here, which on further simplification gives 2 2s, 2 10s, that is 3.5. Therefore, mean deviation from mean is 3.5 as obtained for the given table, discrete frequency distribution table, and this is how we find the mean deviation from mean for a grouped data. Now let's find mean deviation from median and see how the mean deviation can be calculated from median. So to take this example problem, I have a table, a discrete frequency distribution table with initially xi's and the frequency fi's, and the scores here are 6, 9, 3, 12, 15, 13, 21 and 22, and my frequency here is 4, 5, 3, 2, 5, 4, 4 and 3. Now using this, let's see how we can find mean deviation. So now that we have the formula for mean deviation, which is given by mean deviation from median is given by the formula sigma I running from 1 to n fi mod xi minus b by sigma I running from 1 to n of fi, where b is the median which we are going to calculate for the score. So let's see how we can calculate the median, and then finally that median will give me fi, or first I find xi minus b, the deviations xi minus b, and then mod xi minus b, and then I find each of the frequency multiplied with respect to absolute values of the deviations, which gives me the overall mean deviation which we're going to calculate. So initially, to start with, let's find sigma fi, which is 4 plus 3 7, 11, 16, 17, 18, 21, 25 and 30. So my sum of all the frequencies is 30, which I obtain when I add them. Now how to find the median? To find median b for the given problem, let's see how we can find the median b for this score. Now in order to find the median, the given scores or xi's and fi's are respectively arranged in ascending or descending order Therefore, these values which are not in ascending or descending proper order, we arrange them in ascending or descending order and then find the median, which is the middle value of the given observations. So let's arrange these values in ascending order, the lowest to the highest. Now the next measure of dispersion is variance. Now that we have discussed about limitations of the mean deviation, because mean deviation has its deviations which may cancel with positive and negative signs. Therefore, we are forced to take the absolute value of the deviations. In order to avoid the cancellation of the deviations, we introduce the concept of variance, where we square each of the deviations and consider the formula for variance. So once each of the deviation is squared, it becomes a non-negative or a positive value, such that the cancellation or nullifying of the deviations does not arise. So in this case, let's see how variance is derived for its formula. Now let there be n observations, x1, x2, x3, so on and so forth till xn. So here there are n observations for which my arithmetic mean, let this be n distinct observations or the data which I have, and let arithmetic mean of all these observations be denoted by x bar. Now with these two basic informations, then I consider the variance formula. The variance, which is generally denoted with sigma squared, is how we denote, is given by one by n sigma I running from 1 to n of xi minus x bar whole square, is how we define the variance. So variance is also sometimes denoted by V or sigma square, and it is given by the formula 1 by n summation I equal to 1 to n xi minus x bar whole square. So as I observe here, this is the deviation which is squared, whereas in the previous case of mean deviation, we have taken the absolute value of the deviation, but here we take the square of the deviation, is how it gets differentiated from the deviations of the mean deviation. So therefore, we just derive this with where n is number of observations, x bar is arithmetic mean of all the observations, and xi minus x bar are all the deviations which we consider. So based on these three, we define the variance as sigma squared or V, and it is given by the formula 1 by n summation sigma I equal to 1 to n xi minus x bar whole square. So the next measure of dispersion is the standard deviation. Now variance and standard deviation are said to be very much associated. So instead, we define standard deviation derived from variance. So standard deviation is derived from variance. Let's see how it is derived from variance. Now, as we have the variance formula, which we have discussed as the variance V, which is given by sigma square, is equal to 1 by n summation I running from 1 to n of xi minus x bar whole square. From this, it is simply the standard deviation is the standard deviation is nothing but denoted by SD, is given by sigma, that is the square root of variance. It's very simple. It is defined as the positive square root of variance. So when I say standard deviation, I need to find variance and just find the square root of that variance. I get standard deviation. The positive square root is the standard deviation of the given observations. Therefore, standard deviation is given by sigma, that is root V, that is 1 root of 1 by n sigma I running from 1 to n of xi minus x bar whole square under root is how we understand the standard deviation formula. So this is how we define the standard deviation, which we can define as the positive square root of variance. It's very simple. Once you know variance, do the positive square root and we get the standard deviation. Now let's see one example problem to find the variance and standard deviation for ungrouped data. Say, for example, I take an example problem which says find the variance and standard deviation for the following observations. Say it is 5, 12, 3, 18, 6, 8, 2 and 10. So here I would like to find the variance and standard deviation for this observations. So how do I do that? So let's take the observations which are 5, 12, 3, 18, 6, 8, 2, 10. Now totally the number of observations is 1, 2, 3, 4, 5, 6, 7, 8. That implies n is 8. So number of observations is 8 and each of xi is this. So initially I try to find the arithmetic mean x bar, which is sum of all by 8. So this is 5 plus 12 plus 3 plus 18 plus 6 plus 8 plus 2 plus 10 by 8. So we get this whole divided by 8, and this on adding gives me 64 by 8, which on cancellation gives 8. Therefore my x bar is 8. So using this mean value, I'm going to find the variance and standard deviation using the respective formulae. Now we have the formula for variance, which is given by sigma square, that is 1 by n sigma xi minus x bar whole square, I running from 1 to n, and my standard deviation is root of variance, that is sigma. So using these two, I would like to find the variance and standard deviation for the given problem. Now let's take the tabular form and find each of the deviations using the table. So the given scores when taken in a tabular form, say in the form of xi in the first, which has 5, 12, 3, 18, 6, 8, 2 and 10 as my first score. And with this observation, let me first find xi minus x bar, which I'm going to find as the deviation using x bar equal to 8. Substituted here. Then after this, I find xi minus x bar whole square, and then I get each of this. Interestingly, even n is 8. So let's see how I can find xi minus x bar. Now my first xi is 5 and x bar is 8. So 5 minus 8 is minus 3. 12 minus 8 is 4. 3 minus 8 is minus 5. 18 minus 8 is 10. 6 minus 8 is minus 2. 8 minus 8 is 0. 2 minus 8 is minus 6. 10 minus 8 is 2. Now I don't want the negative terms because they lead to cancellation of the entire process, thus nullifying. Therefore, I take square of them in finding the variance or the standard deviation. So in order to find this, I'm going to square each of the second column. So minus 3 whole square is 9, 4 squared is 16, minus 5 whole square is 25, 10 squared is 100, minus 2 whole square is 4, 0, 36, and 4. So this is how we get the column. Now when I add up each of these, I get this when added sigma I running from 1 to 8 of xi minus x bar whole square would be addition of each of this, which gives me 194. So I use this in substituting in the formula so that I get the answer. So when these added gives me summation this. So let's substitute in the formula here. So with the values as obtained, let's find with n equal to 8 and summation I running from 1 to 8 of xi minus x bar whole square is 194. I substitute in the variance formula, which says variance is sigma square, that is 1 by n sigma I running from 1 to 8 xi minus x bar whole square. So using this formula, I have 1 by n, which is 1 by 8 times sigma's ithers being 194. Therefore 194 substituted here divided by 8, when divided gives me this by 8, that implies this is 24.25 when divided with 8. Therefore variance is 24.25 is how we find the variance. 24.25 is the variance. Similarly, let's find the standard deviation for the same problem. Now next, it's about to find standard deviation. So we all know that standard deviation is very much associated with variance. Therefore, when my variance I obtained is 24.25, then my standard deviation is root of variance, that is given by sigma, that is root of variance is root of 24.25, which approximately, on finding the root of 24.25, the decimal value gives me approximately 4.95. This is how we find the standard deviation. Therefore, once we know the variance of the given data, we can easily find the standard deviation by simply finding the positive square root of that variance. Therefore, standard deviation, generally denoted by sigma, is given by approximately 4.95. Is how we understand the difference between the variance and standard deviation, which is the positive square root of variance. So now that we have discussed about the variance and standard deviation for a group data, for an ungrouped data, now let's see how we can define the variance and standard deviation for the group data. So the group data is again classified into two types, where we have the discrete data and the continuous data. So therefore, in order to find the variance or standard deviation of discrete frequency distribution, and continuous frequency distribution, we have the two different classifications. One is discrete frequency distribution and the other is continuous frequency distribution, through which we define the variance and standard deviation. So for this, I have my variance denoted by V, or my variance formula is given by sigma square, that is 1 by n sigma I running from 1 to n fi xi minus x bar whole square. So this is what we define for this, where n is sigma fi, I running from 1 to n, that is sum of all the frequencies is denoted by capital N, and xi for I equal to 1, 2, so on and so forth till n, xi is called our scores, or the data, or the observations. So each xi are the given scores. So this is how we define for discrete frequency distribution. Similarly, when it comes to continuous frequency distribution, we have, of course, here the standard deviation is nothing but root of variance, that is sigma, which we define in universal. So once we know the variance, the square root of variance, the positive square root of variance is the standard deviation. Similarly here, when I come to this, my variance in case of continuous distribution table is given by sigma square, that is 1 by n sigma I running to 1 to n fi xi minus x bar whole square. But in case of this, I have my score, the only difference being that where n is sigma I running from 1 to n of fi, and xi for I equals 1, 2 till n are midpoints of each respective classes. So here the only difference is that xi's are midpoints and here the xi's are scores. So this is what differentiates between the procedure of finding the variance and standard deviation for a discrete frequency distribution and continuous frequency distribution. And next, the standard deviation here is nothing but, as obtained from variance, is the same formula which we have, as standard deviation is root of variance, that is sigma, which we get from the variance sigma square. Now let's find the variance and standard deviation for a discrete frequency distribution. Let's take an example problem and then find for the respective formula used for that given problem. Now suppose I have the score which is xi and the frequency fi, say for example, are given as 4, 8, 11, 17, 20, 24, 32. And my frequency is 3, 5, 9, 5, 4, 3, and 1. So with this course of xi and fi, I would like to find the variance and standard deviation for this entire discrete frequency distribution table. So in order for that, I need to find first xi fi in my second note, and then minus x bar, and then xi minus x bar whole square. So let's find each of them and then find to a conclusion on how we can find. And then finally we have to find fi times xi minus x bar whole square. So let's find each of them for these given scores. So initially my n is sigma fi, which is nothing but, when added up, I get this all added to be 3 plus 1, 4, 4 plus 4, 8, plus 5, 13, plus 9, 22, 25 and 30. So I have my n, which is 30. Then let me find xi times fi, that is 4 3s, 12, 8 5s, 40, 11 9s, 99, 17 5s, 50, 85, 4 2s, 80, 24 3s, 60, 72 and 32 times 1, which is 32. Is how we get each of the scores as obtained. Now let's see how we can find x bar, as we know that to find arithmetic mean x bar for this score, I have my x bar, which is sigma fi xi by sigma fi, which is the formula out here. That is I running from 1 to 1, 2, 3, 4, 5, 6, 7, and here I running from 1 to 7. My sigma fi xi can also be found here by adding each of these, which when added gives me 420 when added up. Therefore, my sigma fi xi, which is 420, and my sigma fi, which is 30, are substituted for the numerator and the denominator as calculated from the given table. This on cancelling gives 3 1s, 3 4s, that is 14. Therefore, x bar is 14. That is the arithmetic mean of all the given scores, and the frequency is 14. So using this 14, I will try to find the deviations for each of the scores, where 4 minus 14 gives minus 10, 8 minus 14 minus 6, 11 minus 14 is minus 3, and 17 minus 14 is 3, and 20 minus 14 is 6, and 24 minus 14 is 10, and 32 minus 14 is 20, 12, 18 is what we get. And for this deviations, I square the deviation so that I get this. Minus 10 whole square is 100, minus 6 whole square is 36, this is 9, and 9, and 36, and 100, and 18 square is. So here we get this 18 square, which is 324. Now with this, when multiplied with the frequency, gives 3 times of 100, which is 300, because this and this multiplied gives the last column. 3 multiplied by 100 is 300, and 5 multiplied by 36 is 150, 180, and 9 times of 9 is 81, and 5 times of 9 is 45, 4 times of 36 is 120, 144, 3 times of 100 is 300, and 324 times of 1 is 324, is how we obtain the last column. Now, in order that I want to find sigma I running from 1 to 8 of fi xi minus x bar whole square, I need to add. So when all these are added, I get this to be 1374, which on addition gives me 1374. So now that we obtained each of these, let's see how we can find the variance and standard deviation using the respective formulae. Now, to find the variance, we have the formula for variance. That is, before that we have found sigma fi xi minus x bar whole square, I running from 1 to 8, 1 to 7, sorry, there are 7 scores. So I running from 1 to 7 of this is 1374, and my n, which is sigma fi I running from 1 to 7, is nothing but 30. Using these two, let's see how we can find the variance of the given problem. So variance denoted by sigma square is given by 1 by n sigma I running from 1 to 7 fi xi minus x bar whole square. So this on substitution gives me 1 by n times of sigma fi xi minus x bar whole square, which is 1374 I substituted from here. Now this on simplification gives me 1374 divided by 30 gives me approximately 45.8. Therefore, it concludes that variance of the given problem is 45.8. So variance is 45.8. So let's find the standard deviation. So in order to find standard deviation, we know that we have the variance V is given by 45.8, which we have found. Using this, we know that the standard deviation is given by root of V. Therefore, when we just square root this, I get this as root of 45.8, which is approximately 6.77 when calculated through the calculator. Therefore, standard deviation denoted by sigma is approximately 6.77 is how we understand the variance and the standard deviation found for the discrete frequency distribution table out here. Now here we have the standard deviation of continuous frequency distribution, which is derived for an alternative formula, because sometimes this computation is modified because the computation becomes the computation of the higher values becomes very difficult in case of the previous formula. So we derive an alternative formula where the computation of the values becomes easy. So here with the alternative formula, we have the variance V is given by sigma square, which is 1 by n sigma fi xi minus x bar whole square I running from 1 to n. So this, let's see how we can derive for an alternative formula. Now when I expand this, I get this to be I running from 1 to n of xi. Now this is a minus b whole square, which is a square plus b square minus 2ab. When expanded with the formula a minus b whole square, this reduces to this. This on further simplification gives 1 by n sigma I running from 1 to n fi xi square plus sigma I running from 1 to n fi x bar square minus sigma I running from 1 to n fi into 2xi x bar is what we get when we expand through this multiplied with this multiplied with this, and this multiplied with this. So expansion of the summation gives this, which when continued here gives us 1 by n of sigma I running from 1 to n fi xi square. Now here x bar square is independent of I, so it can come out of the summation, because summation depends on the value of I, because x bar does not have I. So x bar square comes out of the summation, so that I get x bar square summation I running from 1 to n of fi, and then similarly here 2x bar comes out of the summation as minus 2x bar summation I running from 1 to n of xi fi is what we get. Now proceeding similarly further I have this 1 by n sigma I running from 1 to n of x fi xi square plus x bar square. Now sigma fi is n because we know that n is this n as sigma I running from 1 to n of all the frequencies, the sum of all frequencies which I have substituted here, and then minus 2 x bar. Also I know that my x bar is sigma fi xi by n. So therefore when I substitute this in place of x bar, I get this to be sigma fi xi is nothing but 2n times of x bar, n times of x bar, because this is n into x bar. So in place of this I substitute n x bar out here. So this on further simplification gives 1 by n summation I running from 1 to n fi x I square plus n x bar square minus 2n x bar square is what we get. Therefore when I split this, I get this as 1 by n summation I running from 1 to n fi xi square plus nx square minus 2nx square is minus n x bar square, which on expansion through brackets gives me 1 by n summation I running from 1 to n fi xi square, and this n gives me minus x bar square is what we get. So continued from here, let's see how we get the alternative formula for the variance or the standard deviation. Therefore after deriving, I get my variance, which is sigma square, as 1 by n summation I running from 1 to n of fi xi square minus x bar square, where my x bar we know is sigma fi xi by n. Therefore using this, sigma fi xi whole square by n square, which is how we derive the formula. Now let's see how the standard deviation is obtained from the given formula. Therefore the standard deviation in its alternative formula denoted by sigma is 1 by n summation I running from 1 to n fi xi square minus summation fi xi by n whole square, which is taken as the positive square root of, this is the standard deviation of the given problem. So this is the alternative formula for standard deviation, which can be computed using fi xi square and fi xi on the whole. Now let's see how to find variance and standard deviation for continuous frequency distribution in case of using the step deviation method. By step deviation method. Now by step deviation method, why do we need to use the step deviation method sometimes is also very important here, because sometimes what happens is that when we use the formula for variance and standard deviation, we get, sometimes we have very large values of midpoints xi's. That is, when for large values of xi's, we have, it is difficult, it is time consuming to calculate mean and variance. So in order to avoid this time consumption of finding the mean and variance for large simplifications or large calculations through roots, we try to use step deviation method to avoid this problem. And therefore, let's see how step deviation method can be used in finding the standard deviation or the variance. The step deviation method applied here. So let's find the variance and standard deviation for continuous frequency distribution by using step deviation method. So here my standard deviation denoted by sigma x is given by the formula h by n positive square root of n times sigma fi yi square I running from 1 to n minus sigma fi yi I running from 1 to n of whole square is what is defined for the standard deviation sigma x, denoted by this, is equal to this, where h is class size, n is sigma I running from 1 to n of fi, and most importantly here this yi is very important. That is, in this case my yi is nothing but xi minus a by h for each of I running from 1 to n, where a is assumed mean. So with this assumed mean, we try to find yi, which is xi minus a by h for each I running from 1, 2, 3, so on and so forth till n. So for I running from 1 to n, my yi is xi minus a by h, which I'm going to find and substitute in case of the formula. So standard deviation being this. And note, if I know the standard deviation, then I can easily find the variance, because variance is square of standard deviation, that is sigma x whole square. So once I find, using this formula, I square the standard deviation, I get the variance. Is how we understand the variance and standard deviation for continuous frequency distribution table using step deviation method. Now let's take an example problem where we find the variance and standard deviation for continuous frequency distribution using the step deviation method. So the question here is that I had to find the variance and standard deviation of the given table, which starts out here. Therefore, we have a table of each of the class interval and the frequencies as given here, starting with 30 to 40, 40 to 50, 50 to 60, 60 to 70, 70 to 80, 80 to 90, and 90 to 100 as given out here. Now let's see how we can find for the given frequencies, which are 3, 7, 12, 15, 8, 3, and 2. So for this class interval and frequency, we need to find the variance and standard deviation using the step deviation method. So in this case, I have the class interval and frequency as given, for which I need to find variance and standard deviation. Now here I clearly take xi, which is mid of the class interval. So the mid xi which I take here will be here, and then after that I take xi. So the mid value of xi is 30 to 40, which is 35, and 45, which is mid of 50 to 60 is 55, and this is 65, and this is 75, and this is 85, and finally this is 95. So using this in the form of 35 to 95, we take the mid x through which we simplify. Now next is the deviation yi, which is given by the formula xi minus a by h, through which we are going to find yi. So we use this and find. Before that, we need to find the assumed mean a. Now for this, the assumed mean is nothing but the middle of the class interval which I take, which is the mid class, and middle value of this is the assumed mean which we take. So assumed mean is taken as 60 plus 70 by 2, which gives me 130 by 2, that is 65. Therefore assumed mean a is 65, which I consider out here. And then h is class size. Now as I see that the class size is clearly the length of each class, which is 10, therefore h is 10 out here. So using the value of a equal to 65 and h equal to 10, I'm going to find each of the scores. So as I see here, my first score, which is y1, is calculated using x1 minus a by h, which on simplification gives x1, which is 35, minus a, which is 65, by 10. This on simplification gives minus 30 by 10. This is minus 3. So for the first value, my y1 is minus 3 as obtained through this formula y1 equals x1 minus a by h. Similarly, if I want to find y2, then 45 minus 65 is minus 20 by 10, which is minus 2. Then 55 minus 65 is minus 10 by 10, which is minus 1, and this gives me 0, and this gives me 1, and this gives me 2, and this gives me 3. So each of the deviations I get by substituting in the formula, and I get each of y1, y2, y3 till y7 using the formula. Now next comes on finding yi square. Because I don't want the negative terms out there, I simply find square of each of yi. That is minus 3 whole squared is 9, minus 2 whole squared is 4, this is 1, 0, 1, 4, and 9. So once that yi squared is obtained, then the question is on finding fi yi, which is nothing but multiplying fi with yi, and then I get this to be minus 9. So therefore I get fi times yi when multiplied gives 3 times minus 3, which is minus 9, and 7 times 4, 7 times minus 2, which is minus 14, and 12 times minus 1, which is minus 12, and then 15 times 0, which is 0, and then 8 times 1 is 8, and 3 times 2 is 6, and 2 times 3. Therefore fi yi is this times this is 6, and 2 times 3 is 6. Also I would like to find fi yi square, and then finally find the variance and standard deviation. So how do I find fi yi square? Now that I have found yi square and fi, I'm going to multiply these two, where 3 times 9 is 27, and 7 times 4 is 28, and 12 times 1 is 12, and 15 times 0 is 0, and 8 times 8, 8 times 1 is 8, and 3 times 4 is 12, and 2 times 9 is 18. Is how we get when we multiply fi terms with yi square. Now that we have got the complete table, it is now very important to find n that is sigma fi, which is sum of all these. Therefore, when I want to add each of these, I get this to be 50. So the whole of n is sum of all the frequencies, which is 50, and then next is to find sigma fi yi, which on addition gives sigma fi yi on adding each of these terms gives me negative 15 is how we get. Now when I want to find sigma fi yi square, then adding all these, I get this to be sum of 105 as found in the case. This and all added gives 105 as the value. So with each of these obtained, let's use the formula to find the standard deviation of the given problem. So using all the values as obtained here, the class size, which is 10, and the value of n, which we have obtained, which is 50, and my sigma fi yi, which is negative 15 from the table, sigma fi yi is negative 15, and my sigma fi yi square is 105, which we have obtained. Let's find the standard deviation using the formula. We have standard deviation sigma x is h by n root of n times sigma fi yi square minus sigma fi yi whole square is what we have as the formula for the standard deviation. So therefore, substituting each of h and this in the formula, we get sigma x is h, which is 10, by n, which is 50, times root of n, which is 50, times sigma fi yi square, which is 105, minus sigma fi yi, which is minus 15 whole square, is what we get. So in simplifying this, I get this to be 1 by 5 root of 50 times 105 is 5 5s 25, 2, 5250 minus 225 is what we get. Therefore, this is nothing but 1 by 5 root of 5250 minus 225 is 5025. This, on simplification, square root of this divided by this gives 14 is 201 under root. Times of 25 by 5, which gives me root 201. Therefore, my sigma x is root 201 as obtained here. Now let's see how we can find the variance of the given problem. In order to find variance, my standard deviation, which was sigma x, was obtained as root 201, which is approximately 14.18. So using this value of standard deviation, we try to find variance, where variance is given by the formula, which is sigma x square, that is square of the standard deviation, so which is root 201 whole square, which is 201. Therefore, I get my variance V is equal to 201 for the given problem. Therefore, my standard deviation is approximately 14.18 and my variance is 201 for the given problem with the class interval and frequency using the step deviation method. The next is coefficient of variation. What is coefficient of variation? To define this, The simple definition for coefficient of variation is that it is a kind of a measure of variability or dispersion. It is how we define the coefficient of variation, is defined as the measure of variability or dispersion. Why does we need to take into inclusion? What is the need for inclusion of coefficient of variation? Now that we have studied the three measures of dispersion, the range, the mean deviation and the standard deviation, what is it that is essential for introducing coefficient of variation is the biggest question here. Now what happens is, sometimes we have the mean which is same for both mean deviation and standard deviation, and generally they have the same units. So when the units differ, definitely the deviation becomes difficult in studying in respect to the data. So in order to define the units, or in order to define a value which is independent of the units of mean deviation or standard deviation, we define the coefficient of variation as the measure of variability which is independent of units. Note, but before I take the note, I take the measure of variability which is defined by coefficient of variation of a distribution denoted by CV is nothing but given by the formula sigma by x bar times 100 is how I define the coefficient of variation for this not equal to 0, and this where this is the standard deviation and this is the mean or the arithmetic mean of the given distribution table. So the coefficient of variation is given by sigma by x bar times 100, which is taken as the formula for CV. And it is very important to note that coefficient of variation is independent of units, is how we have the note which defines the measure of variability. Coefficient of variation is independent of units, and hence it is essential that sometimes we consider the coefficient of variation as the strict measure of variability or dispersion. Now that we have discussed about the coefficient of variation and its respective formula using the standard deviation and mean, now comes the significance of coefficient of variation. Where is the coefficient of variation useful in the problems or in the branch of statistics is the biggest question out here. So mostly the coefficient of variation helps us in comparing the two distributions or the two series or more than two series. So here it is nothing but coefficient of variation is said to be a relative measure of variation. So the word relative itself shows that it is a measure of variation in relativity to the other distribution or in comparison of two distributions considered in the problem. So therefore, in order to find this, let me take two distributions. Distribution A and distribution B, through which I have two distributions having their own respective data. Then in this case, I can compare these two distributions using the following points. If coefficient of variation of A is greater than coefficient of variation of B, then that implies data of distribution A is more varied, is how we understand. That is, if coefficient of A is greater than coefficient of variation of B, then the data of the distribution A is more varied to that of A, to that of B. So greater the coefficient of variation, greater is the variation of the data which we take into consideration. So here this greater than this implies this, the data of the distribution A is more varied and far apart as compared to the distribution B out there. So let's see what happens to the second property which we are considering here. With the first property, let's come back to the second property, which states that lesser the CV value, more consistent or homogeneous is the distribution as compared to that of the other. That is, say for example, my distribution B has less CV value. Then what happens? In case of distribution B which has less CV value, here more consistent will be the distribution B, or more homogeneous will be the distribution B, which are inversely proportional. Therefore, lesser the consistent value, coefficient of variation value, more consistent is the distribution as compared to that of the other distribution, which we consider in relativity. So next we will see comparing of two frequency distributions which have the same mean. So let's see how coefficient of variation helps us in the relative measure of two distributions when they have same mean. So comparing two frequency distributions with same mean is how we understand this concept. So let's see how we can compare the two frequency distributions which have the same mean. So in this case, we see that if I have two distributions, let D1 and D2 be two distributions with same mean, that is their mean value is same. That is, if I take the distribution D1 and D2, for this distribution D1 and for this distribution D2, let's see how we can compare here. Now this is with both. Now since they have same mean, the distribution, the mean of this D1 and the mean of D2 is both equal to x bar. Therefore, the mean here is x bar, and again the mean here is also x bar because they have the same mean. Now let the standard deviation of the distribution D1 be sigma 1 and the standard deviation of distribution 2 be sigma 2, which are not same. Therefore, in this case, the coefficient of variation of distribution D1 is given to be sigma 1 by x bar into 100, and for this the coefficient of variation of distribution 2, that is D2, is given by sigma 2 by x bar into 100 is what we get for this. Now the question comes, how do we change what happens when sigma 1 and sigma 2 are varied with their values? What happens to the coefficient of variation of the respective distributions with change of sigma 1 and sigma 2? Of course, x bar being fixed and same is how we compare with the standard with the distributions d1 and d2 through the sigma 1 and sigma 2. Now, therefore, in case of the two distributions which we have seen for d1 and d2, my coefficient of variation for this is sigma 1 by x bar into 100, and here it is sigma 2 by x bar into 100 for each of the distributions d1 and d2. And it is very important to note the CVs are decided on the basis of their values of sigma 1 and sigma 2. So therefore, the two distributions are studied under coefficient of variation on the basis of the values of sigma 1 and sigma 2. Because the mean is fixed, we study the two distributions under the coefficient of variation strictly on the basis of the values of sigma 1 and sigma 2. So what happens when sigma 1 is lesser value of standard deviation implies more consistent is that distribution. So for consistency of the distribution, lesser the value of standard deviation, more consistent is that distribution, and higher value of standard deviation implies more dispersed is the distribution, is how we study the two properties, where lesser value of this implies more consistent is the distribution, and higher value of this implies more dispersed is that distribution. So based on the greater or lesser values of standard deviation for fixed mean, we decide on the standard deviation for the distribution being more consistent or more dispersed, is how we compare in this case. And the question is, which section has greater variability in performance, where it is given that in this problem, for comparing analysis through two frequency distributions with same mean, here I have a question which says, students of section A and B of a class show the following performance in a test which is conducted for 100 marks. Now here is section A and section B, and the number of students in section A are 50 and the number of students in section B are 16 number. Now average marks in the test of section A is 45 and average marks in the test for section B is also 45. So the whole of average is 45 in each section. So this gives us the condition that it has same mean. That is, for same mean we use the condition where this example exactly fits in with same mean. Now it is also given that variance of distribution of marks for section A is 64 and section B is 81. Now the mean x bar of A is 45, which is equal to x bar of B, which is with same mean. Therefore, same mean. Now similarly, variance of distribution A is 64 implies standard deviation of A is root of variance of A, that is root 64, which is 8. Therefore, standard deviation of A is 8 and variance of B is 81, implies standard deviation of B is root 81, which is 9. Therefore, standard deviation of B is 9. Is how I get the standard deviation of section A is 8 and standard deviation of section B is 9. Now, therefore, clearly standard deviation of B is greater than standard deviation of A, as can be seen since 9 is greater than 8. Therefore, the class with greater standard deviation will have more variability, is how we understand. Therefore, let's try to understand the question which says which section has greater variability in performance is strictly based on deciding on the value of standard deviation. Therefore, greater the value of standard deviation, greater will be the variability of that section. Therefore, I have sigma B is greater than sigma A. Therefore, for same mean, we have studied that the section with greater value of standard deviation will have greater variability, will have more variability, is how we understand. Therefore, sigma B greater than sigma A, as we have seen, implies section B has greater variability in performance. Greater variability in performance. So, strictly with the value of standard deviation, I could obtain that because the standard deviation of section B is greater than standard deviation of section A. Section B has greater variability in performance is the answer for the given question of the table of values. Now, in this case of directly, let us understand the concept of comparing two frequency distributions with unequal means directly with an example problem. So, let's see an example problem which says lives of two models of refrigerators A and B obtained in a survey are given below. So, in this case, the life is given in years and model A of the refrigerator and model B of the refrigerator is given out here. That is, for the first 2 years, 0 to 2, the model A was 5 and model B was 2, and so forth, 2 to 4, 4 to 6 is what is the data given. Now, the question of this problem is which refrigerator model, the question here is which refrigerator model would you suggest want to purchase is the question out here. That means based on the information given out here, the question what we have is which refrigerator model would we suggest one to purchase, or which refrigerator model would I purchase based on the statistic information I get in online search of the life of the refrigerators in years and model of the different refrigerators. So, these kind of problems are generally based in the question which says which refrigerator model would you suggest one to purchase. Then this is totally based on finding the mean, the standard deviation, and then the coefficient of variation through which we can decide on the deciding of the best purchasing model based on the coefficient of variation which we are going to find. So, once the coefficient of variation value is compared for model A and model B, then we will try to compare on the better model which we can purchase based on the coefficient of variation for unequal means and unequal standard deviations. Now, as we take the table for model A of the refrigerator and model B of the refrigerator, because I need to find the mean and standard deviation, I need to classify the table with all its respective contents. Now that the class interval and the frequencies are given for both model A and model B, then in this case, initially I find the mid value of this class interval with 0 to 2, which is 1, and here it is 3, it is 5, it is 7, and this is 9. Now that I have obtained xi, I can find fi xi by multiplying 1 times of 5, which is 5, 3 times of 16 is 48, and 5 times of 13, which is 65, 7 sevens, 49, 9 fives, 45. Similarly, I can find fi xi square, where I can square this and multiply with this. 5 times of 1 square is 5, 16 times of 9 is 90, 138, and fi xi square 13 times of 25 is 25, 250, and 75 is 325. And similarly, 7 times of 49 is 343, and 5 times of 81 is 8 5s are 40, which is 405 is what we get here. Similarly, I'll try to fill up these two columns, where for model B my frequency is 2 and my mid value is 1. So 2 times of 1 is 2, and 7 times of 3 is 21, and 12 times of 5 is 60, and 19 times 7 70, and 7 9 63, 133. 9 nines 81 is what we get here. Now again, squaring xi square and then multiplying with fi. 1 square times 2 is 2, 9, 7 nines 63, and 12 into 25, 250 and 50, which is 300, and 19 times 49 x squared. 49 is 9 nines 81, 9 ones 9, 17, 9 fours 36, 4 ones are 4, 7, 1, 8, 9. So this is 931, which we get here, and then this is 9 times 81, 81 times 9, which is 729, which is obtained for the whole of the table. Now let's find each of n. Here my n is sigma fi, which on simplification gives me 46, and in this case my sigma fi xi is which on simplification gives me 212. This is 212, and this is sigma fi xi squared. When I add up, I get 1221 on each of addition, and then my sigma fi in this case is 49 when I add up, and when I add each of them, I get here 297, and this on addition gives 2025. Is how each of the values are obtained, where this is sigma fi xi, and this is sigma fi xi squared, sigma fi xi. So here for model A, I would like to find the mean, for which my xa bar, which is the mean of model A, is given by sigma fi xi by n, that is sigma fi. So in this case, I get that when I is running from 1 to n, my sigma fi xi in case of this is 212, that is 212 divided by n, which is 46 in this case. So therefore, the mean of x for model A is 212 by 46, which on simplification gives 2 ones, 2 6, and then I get this to be 4.6. So therefore, the mean of model A is 4.6, and similarly for model B, let's find the mean. Now in this case, the mean of model B given by fi xi by n is for this, which gives 297, because for model B sigma fi xi is 297 by n for model B is 49, which on simplification gives the mean of model B is 6.06. So this is how we find the mean of model A and the mean of model B. Next, we find the standard deviation of model A and the standard deviation of model B. Now let's find the standard deviation for model A. So for model A, the standard deviation is given by sigma A square, which is given by the formula sigma fi xi whole, if sigma fi xi square by n minus sigma fi xi by n whole square, where for model A we have each of the contents here, where if I take sigma fi xi square is 1221 out here, therefore 1221 by n, which is 46, minus sigma fi xi, which is 212, and by n, which is 46, and this whole square, and on simplification through calculator I get the value of this as approximately 5.38 is the value. Therefore, standard deviation is the variance is 5.38, and that implies standard deviation sigma A is root of 5.38, which comes out to be approximately 2.319. Therefore, standard deviation of model A is 2.319 is how we find the standard deviation of the model A. Similarly, we find the standard deviation of model B in the similar process, and then we find the value of that standard deviation. So for model B, let's see how we can find the standard deviation using the similar process as that of model A. So here my variance is given by the formula sigma fi xi square by n minus sigma fi xi by n whole square, through which we are going to find the variance initially for model B. Therefore, sigma B square is sigma fi xi square, which is 2025 by n for model B, which is 49, minus sigma fi xi, which is 297, and again by 49 whole square. So this on simplification through a calculator gives me the value 4.61. So therefore, the standard deviation for model B, sigma B, is given by root of 4.61, that is root of 4.61, which I calculate here, is nothing but the approximately 2.147 is what we get as the standard deviation of model B. So now that we have obtained the mean of model A and B and the standard deviation of model A and B, now comes the question of finding the coefficient of variation of model A and B. So next is to find the coefficient of variation of each of the models A and B. Now next is to find the coefficient of variation of model A. So to find coefficient of variation of model A, we have the formula which says coefficient of variation of model A is nothing but sigma A by XA bar, that is mean of model A times 100. Therefore, using h of sigma A, we know that we have obtained the value of sigma A as 2.319 by the mean of model A, which is 4.6 times 100, which on simplification through a calculator gives me this to be 50.41. Therefore, coefficient of variation of A is 50.41 for the model A. Similarly, let's find the coefficient of variation of model B. So now that we have the standard deviation of model B as obtained as 2.147 and the mean of the model B, which is 6.06, then the coefficient of variation of model B given by the formula sigma B xB bar times 100 gives me with the value sigma B, which is 2.147 by 6.06 times 100, which gives me the value of this as 35.543 approximately. Therefore, coefficient of variation of model B is approximately 35.43. Now that we have obtained the coefficient of variations of two models A and B, let's see how we can compare through the measure through unequal means, comparison through unequal means. So now that we have found the coefficients of variations of model A and model B, now comes in comparing and trying to know which model is the better one to purchase for future. So for this, let's consider the comparison through coefficients of variations, where the coefficient of variation of model A was 50.41, which I have obtained, and coefficient of variation of model B, which was obtained as 35.43. Now, here we clearly see that the coefficient of variation of model B is less than coefficient of variation of model A, because 35.43 is less than 50.41. Now, since this is less than this, that implies model B is more consistent than model A, is how we understand. That implies is more consistent model B in terms of the refrigerator's life in years, in terms of life in years. Therefore, this makes us understand that if model B is more consistent than model A in terms of life in years, then definitely I would say model B is the better one to choose, because this is more consistently going to stay with me for life in years. That implies model B is the right model of refrigerator to be purchased, is how I conclude through the given values. So model B is the right model of refrigerator which I need to purchase on the given information of the class intervals and the respective frequencies of model A and model B with life in years. Model B is the right model I'm going to purchase.